Here's one for you to try. We have solved the rational inequality, and it's y squared plus 15 over 8y less than or equal to 1. First off, don't worry about the fact that this is a y instead of an x. Just treat it like an x. It's the same. It works exactly the same. Second off, I wanted to bring up the steps to solve this. Okay, so pause the video, solve the problem, and then we'll compare notes on the other side. Okay, let's do this together. First off, did you multiply up by 8y and solve? That's so tempting, isn't it? But it's incorrect for these. We need to leave that 8y in the denominator so that we can account for the asymptote there, because this rational inequality can change between positive and negative at the asymptotes. So that would have been incorrect, unfortunately. So you have to be really careful. Let's follow these steps. Step 1, make sure 0 is on one side of the inequality. Okay, we have 1, so we need to subtract that 1 off from both sides. So that gives us y squared plus 15 all over 8y minus 1 less than or equal to 0. So there we go. Check. Step 2, if it's a rational equation, and it is, combine over a single LCD. So let's get a least common denominator of 8y. Okay, so 8y is what we need, so I'm going to multiply by 8y over 8y right there. That gives us y squared. I'm just going to rearrange a little bit. Minus 8y plus 15 all over 8y less than or equal to 0. Okay, so notice how I'm leaving that 8y in the denominator there. That's just what we have to do for these kinds of examples. Okay, so there we go. Step 3, solve the related equation. Set both the numerator and the denominator equal to 0. Okay, well, let's do that. Let's do the numerator equal to 0. That's a nice trinomial that we can factor. So we have y squared minus 8y plus 15 equals 0. Factor that out. Let's see, how about minus 3 minus 5. Looks like that does the trick. So that gives us y equals 3 and 5. That's the numerator. From the denominator, we have 8y equals 0. Divide both sides by 8 to get y equals 0. Okay, so we have 3 different regions to check. We have 0, 3, and 5. Okay, so let's do that. Let's see, so we solve the related equation, related equation, check. Now we'll separate the number line into regions and do some testing. Okay, so a bit of tedium associated with these problems, actually. Just take some patience, right? So here's one region at 0. We have another one at 3, and another one at 5. I'm pretty careless with this because it's not an exact, right? We're not really doing this it doesn't really matter. It's just so we can see what's going on. It helps us visualize what's happening here. So I'm not putting in all the tick marks between or anything like that. Let's pick some test points. Now the test points can be anywhere in the regions, but you cannot use an endpoint as a test point. We already know that the endpoints of these regions are zeros or asymptotes, so it wouldn't do us any good to use this as a test point. Those are the only points we can't. So let's test, how about -1? Here, x equals 1, so we'll do x equals, be consistent. Between 3 and 5, let's do x equals 4, and then on the right of 5, let's do x equals 6. Okay, so we'll go ahead and test each one of these points into the factored form. Factored form, which I've underlined over here, because that's especially important. Factored form of the equation. Okay, so here are the points, and we're plugging into the factored form of the equation. So we'll use y minus 3 times y minus 5 all over 8y. Okay, so plugging in, so x, okay, so I guess these should all be y's here, so let's change those to y's. Y, okay, so y equals -1. We plug that in, we get y minus, -1 minus 3 is -4, so that's a negative. Negative 1 minus 5 is negative 6 negative. 8 times negative 1 is a negative. Negative times a negative divided by a negative is a negative. It's basically like if the number of negatives is odd, the whole thing is negative. If the number of negatives is even, the whole thing's positive. Let's plug in y equals 1. 1 minus 3, negative. 1 minus 5, negative. 8 times 1 is positive. Negative times negative is positive. Divided by a positive, of course, still positive. Plugging in 4 for y, 4 minus 3, positive. 4 minus 5, negative. 8 times 4, positive. Positive times negative divided by positive is negative. Right, so you see how it's easier to do this in factored form. All right, finally here we have 6. 6 minus 3, positive. 6 minus 5, positive. 8 times 6, positive. Positive times positive divided by negative is all very positive. Okay, let's look at our true false. Now, here, anything that's less than or equal to 0 gets a true. So less than or equal to 0 is stuff that's negative. That's going to go with true. So anything positive is going to get a false. So negative gets a true. In this problem, it changes from problem to problem. Positive gets a false. Negative gets a true. Positive gets a false. Bringing this up to our number line gives, okay, so y equals negative 1 was in this region here. So this whole region down here is true. Positive 1 came from this region, false. 4 came from this region, that was true, and 6 came from this region over here. We have true, false, true, false. The answer includes all the regions that are true. So we're looking at all of this here, all the way down to negative infinity, right, that whole region, and then this stuff here. Okay, so that takes care of step 5. Now, step 6 is be careful to note whether or not interval endpoints belong in the final answer. This is less than or equal to, so because of that equal sign, we're going to include all the endpoints that come from the numerator. So that's 3 and 5, so I'm going to include those like this with a hard bracket. Other people include them with a closed-in circle. However, y cannot be included because it comes from the numerator. We can never include endpoints that come from the numerator. That would give us an asymptote, and we don't include those. So I'm going to do a soft bracket here. Other people do it with an open circle. But actually, we don't even need the graph notation. We'll just do this in interval notation. So here we go. There's step 6, and here's our actual answer. After all of that, we have a nice little answer. We go negative infinity to 0. Then we don't include 0, so we do a parentheses, stop, and then we union over this middle region, and then we start again at 3, and then we stop again at 5. And both of those, we do include the endpoints, so those get the hard brackets.